Hello, this is Robert Casey, and this is analyzing Y-DNA for haplogroup BY9001. This is a predictable haplogroup under FGC11134. This talks about the data collection, followed by a YSNP prediction, and then charting of this haplogroup. So here's an overview of this presentation. First of all, you need to determine which of your SNP branches is both predictable and chartable. And then also, once you know which haplogroup you're going to be analyzing, then you need to start the data collection. And this is 80% of your time in any kind of comprehensive Y-DNA analysis. Once you get the data collected to a certain degree, then you do YSNP prediction, which takes the guess around who belongs in your analysis and who does not. And you don't want garbage in, garbage out, because it's real important to only include the proper testers and not have any speculation enter your analysis. Charting is the best methodology to summarize your analysis. I use SAPP as long as your haplogroup has less than 500 or 600 testers, which is the limit of SAPP. You also need to document and have video presentations to assist others, and that's always a wise thing to do. And this presentation is meant to assist BY9001 testers and researchers to understand all the above steps. So this is why BY9000 was chosen, other than his father, grandfather, or sons and grandsons. First of all, very few surname clusters, only around 10%, have large enough signatures to be predictable under any haplogroup. So you really need to pick one in the time frame of 1500 to 2500 years before presence. And BY9100 is 1630 years before presence. So this is a good acceptable time frame for a branch. Also, you need 15 to 20 branch equivalents in the highest two branches. BY9001 has 23, so it satisfies that requirement. Then you need 50 to 100 testers at Y67, both confirmed and predicted, and BY9001 has 101 testers. You also need at least 7 markers in the YSTR signature. BY9001 has 7, but also has some pretty unique values as well. So these steps lead me to believe that BY9100 is a good candidate for both being predictable and chartable. So once you've determined a particular haplogroup, you start the rather difficult and arduous task of collecting data. If you're under R1B, I go to the big tree, which is also at ytree.net as the URL, to jumpstart my data collection. I also search my master Excel spreadsheet for all of haplogroup R testers to see if some of them show up in my master spreadsheet already. Next, I go to relevant haplogroup projects and surname projects and manually add some more. And then from this list of confirmed testers that are BY9001 positive, including all the branches underneath, then I determine the signature of BY9001. You need at least 7 markers in the signature, and BY9100 has 7, but also has some pretty unique markers as well. So why do you really need YSNP prediction? Most prediction models are either 99 to 100% accuracy, so this eliminates bad data. Even if you only have 5 or 10 testers, have several hundred, those testers that may not be, should be included, might really throw off your chart and your whole analysis by introducing bad data. Old saying of garbage in is garbage out is very true. So that's why YSNP prediction is critical, because it guarantees that the data that you run into your analysis belongs inside your analysis. If you include just a few testers, the accuracy will suffer tremendously that don't belong. YSNP prediction dramatically increases the sample size, because now you can go through and just find all the ones that you think are possibly related run your model prediction and see if they are or not. So this makes a highly productive way to determine who belongs to your haplogroup and who doesn't. Since the formulas can be copied and pasted for new rows, which are new testers, there's a little labor once you've established the first signatures and models. And BY9001 has 100% accuracy, so this is encouraging. It's common to have the same surname in close related people, but do not share the same common ancestor. So you could have the same surname show up several times as several surname clusters under the same predictable haplogroup. A lot of people see that they belong to an older haplogroup and make the immediate assumption that they're all related, and this is rarely the case. People also have a bias to add the same surname testers to incorrect clusters, and they tend to ignore many MPE testers as well, which are very critical for developing Y-share signatures. So here is how you determine the signature for any predictable haplogroup. First of all, this starts with L21 in the first row. These are the most common values of the older haplogroup, which is about 4,500 years old. And this gives you a starting point. And then you take the predictable haplogroup under L21 and you analyze to see if there's any common markers that exceed 75% of a different value than the L21 value. So the first row, the first column that shows up that it has a bunch of 17s. Obviously, they're all but one is a 17, so that's obviously over 90%, so that becomes part of your signature. So then you go on to the next column adjacent to that, where it has 18s, 19s, and 17. Now, the way a signature works is it has, you say 18 or anything greater than equal to 18. So that also includes the 319s. So there's only one tester that doesn't satisfy the signature. Then the next column has all 9s, so that's obviously part of the signature. The next one has 26s and 27s. Now, you could say less than 27 and or less than or equal to 27, and that'd get 100%. But it's better to pick one at a lower value as long as it has 75%. And obviously less than or equal to 26 includes over 75%. So 26 becomes the signature value. The same with on the next ones, you're at 17 and 16s. You say less than or equal to 16, that's all but one, satisfy that. And there's all 11s in a green row. And then there's a row that only has with 14s and 1 13, which counts, and 2 15s, so that obviously belongs to the signature. And so you got 7 markers in your signature from this analysis. Now, I had to delete some rows and columns because some of the other ones look like they may qualify, but there are a lot more rows in this actual spreadsheet. So now that I have all the confirmed testers, I calculate the signature and genetic distance for each one. And I try to find quite a few negative testers that cannot belong to this to train the model. So what you need is about an equal amount of negative testers as you have positive testers. And so the input stream is the FTID, which is optional. This just allows me to figure out what went wrong sometimes. It's just for information only. So what it is, it takes all the ones that are ones and say those are positive, and they have to be confirmed by YSNP testing. And then the ones, the results have 0 means they all been confirmed not to be BY9001. So you have the signature and genetic distances from the signature. And so you take this input file, and this should be in another worksheet on your worksheet. And then you can save this as a CSV file for input to the software program AccuStack, which only costs $10 plus tax. So I ran this through the Accustat, and this is the output. And it shows the results is three numbers. There's a constant, and then there's a multiplier for the signature and a multiplier for the genetic distance. You do that in one formula, and then you just copy and paste for all other rows. And then this is the accuracy that it found. It predicted 100% of all the testers that are negative, and also 100% of the testers. So this has 100% accuracy in all respects. So here's the actual formula for a signature match, and it works pretty simple. A COUNTIF is, if that statement for COUNTIF is true, it's a 1. If it's false, it's a 0. So there's 7 markers, and so there's 7 COUNTIFs. And so if all 7 are true, you get a match of 7. If 2 of them are not true, then you get a match of 5. N is the row is a column that is 390. So all that does is represent the marker value. And V is 389-1. And 20 just means that's the row or the tester that is applying. Every time you copy this formula to a new row, all the row numbers just automatically increment to the proper row value. And so this formula only takes a small amount of time to do. So this is the formula. And then once you copy and paste, there's not much to this. This is a pretty straight issue to create what is the signature match for each particular tester that you're evaluating. Next, you do the formula for the YSNP prediction as well. And the 2.718 number is E. That's the exponential natural log. All kinds of models and scientific formulas include this number. It's actually derived by a mathematical formula in itself. The first number in the after the parentheses is 68.45 number. That's the constant that was derived from Accustat. The plus 19.138 is the constant for K, which is where the signature is located. And then the 9.38 is the multiplier, the constant for genetic distance, which is located in column L. And if you notice, you have that whole equation, and then you have the slash, which is divided by, and it's just 1 plus whatever is in the top line. So you put this in once, and every formula is the same, only the constants change. In this screen, this is the original spreadsheet, and it already has the K and L are the signature match and the genetic distance from the signature. And then DT is the actual formula. And you notice they just all say 1111, so anything greater than 50% is considered positive. So this takes all the guesswork out of what belongs and what doesn't belong. And if you have a new tester, you can just insert a row and then put the new data in, and then copy all the formulas for signature, genetic distance, and the model, and they'll automatically update. So now you've collected all the data and you're ready to analyze it. There's a tool called SAPP, and it creates a chart. And there's some prep work for this, though. You got to copy and paste to a new worksheet called SAPP. The first thing you add in SAPP is you have to enter all the SDR values for Y67 markers. And so in this particular worksheet, you just go back to the original worksheet, copy everything out to the 67 markers, paste it into this new worksheet under the SDR data, and then you delete all the everything but the FTDN ID, which is the key, which is used for every tester, and all the 67 markers. Next, you do the same thing for SNP data. Now, SNP data, you have to convert the format a little bit because SAPP likes to have them in parentheses and a plus. And this is good because if you know it's big Y tested, you can assume that all the sons are negative. So you can put the terminal SNP as the positive one, and then if you know it's big Y tested, you can add 2 or 3 others of the sons and put negative. This really restricts SAPP from being able to predict further down, and so the more negative branches you put in, the more helpful. Then info is just optional fields that you want to show up in the tester boxes. In my case, I always have the family tree data ID, and also I have the actual terminal SNP to see if the prediction is matching what SAPP produces. And also I have both the signature and genetic distance just to kind of sanity check the SAPP. Next, it's wise to enter your own values for the SNP tree. SAPP just can't keep up with all the changes, and you may not use the same YSNP branch because those are constantly changing. So it's better to input your own SNP tree. And I just put in father-son pairs, and it works a lot better. And if you ever come back and add more later, it's a less work to maintain such a list. And here is a Fitzpatrick-Kirkpatrick surname cluster. It's on the right side of the screen in the middle. And so if you look at all the Fitzpatricks, there's only one Allison, and there's one Norton in that list as well. So all these qualify as a surname cluster because as long as you have less than 50% for any particular branch, that works. And so that's how you determine when to stop the upper limits. You can't see the connection on the right, but basically that bottom right portion all connects back up and can be connected to the other portion of the chart. So this is a good surname cluster. And it appears that there probably is 2 surname clusters for Fitzpatrick. And this is the second one. This is in the HTML format. It's a little bit different. This one is a little more on the gray side as being a Fitzpatrick because there's only 8 Fitzpatricks. And I'm assuming that the Fitzclarence is probably an MPE event, but it may not be. Then you got 4 Creightons, 2 Rileys, and 1 Ermode. So this is pushing the 50% MPE rate, but this is obviously an evolving second surname cluster for the Fitzpatricks. Now this presentation gave a very brief high-level overview, and this takes up quite a bit of technical skills, and I'm announcing a Y-DNA analysis service and offerings to do this, and all the funds would be used to buy software coding because I just have not been ever had a very much experience in programming in my life. So data collection is the most time-consuming portion of it, and it's probably 75% of any cost because it just takes a lot of time. But I jumpstart a lot because I have 65,000 testers already in my database, but it's somewhat dated, and I continue to update, but it's almost impossible to keep up with 75,000 testers. It's just a pretty difficult thing because the surnames change, projects go active and inactive. There's a lot of work in maintaining a spreadsheet. Not everyone has the technical skills or the time to conduct such an analysis. I'm doing most of these one at a time, but it takes a while. Testing is not inexpensive, and the family tree tools just really do not provide much help. So this analysis is far superior to the YSTR match list that Family Tree presents. This kind of analysis is now available for a fee and will be used to develop more software tools to assist with the data collection and to get my old L21 SNP predictor updated to work for the new type of YSNP prediction I'm doing now. Updating the Y21 SNP predictor tool to all across haplogroup R, more automation of data collection, and eventually improve charting, which takes a significant amount of effort. And assistance in the data collection, which might be in form of hiring people in Eastern Europe or local kids who can do this, because a lot of it's pretty tedious for data collection. These services will be available for haplogroup R because my database is currently limited to haplogroup R. So the costs are primarily based on the size of the project, because the bigger it is, the more manual labor is collecting all the data. So, and also there are optional charting and manual data collection options as well. So the kind of the three base fees are, if it's a small haplogroup with 10 to 25 branches, it'd be a $100 fee. And then $150 for a medium-sized project and $200 for a larger project. There's only a handful, probably 4 or 5 larger than that, and so those would be custom, and they would take a tremendous amount of time, as SAPP can't handle over 500 testers, so that would become an issue. Charting is an option. You don't have to do charting. If you don't do charting, then it's not going to cost any more. If you want one pass, no special options, you add 20% to the base fees. If you do 2 pass to look for negative branches and modal value, you need to add 30%. Data collection is by far the most time-consuming component of this. So if there's minimal data collection, then there's no charge. This will be going to the 2 most popular projects that have most of the data and collect them. If you want me to moderately add some more by looking at several surname projects or multiple haplogroup projects or geographic projects, you add 20% if I do 10 more projects. If you want extensive manual collection where I look at almost every surname and that's possible, then you add 40%. And that's just for confirmed testers. Then you have the collection for predicted tester, which is much more, because when you look through the data, you don't have the model to tell you which ones belong or not. So you have to kind of sight them by eye and how they belong to certain groups. So the minimal is basically if these testers end up in the same groupings, I will manually collect some of those. That will probably be 10 to 20% more data. If you go hunting through more projects to find more, that's another 20%. And if you do extensive manual collection, that'd be another 40%. And remember, when doing this, probably half the ones that I select and manually extract probably won't even end up being part of your haplogroup. It is very labor intensive to manually update data for analysis. So these are pretty major adders. So this particular analysis, the base fee, since this is 32 branches, would be $150. I did a quick one-pass charting, so that'd be $30, which is 20% more. I did a moderate amount of data collection, so that'd be another $30. I did a minimal amount of data collection for predicted, so there's no charge for that. So it's only a charge of $210, which is well worth it. This is less than a big Y test in this particular case. If you're interested in this analysis service, send me an email with a haplogroup that you're wanting and the characteristics that you're willing to pay for. And I will help you adjust that to make it more realistic and also to work within your budget. Only predictable haplogroups will be considered. And this is in the time frame of 1,500 to 2,500 years. You just can't do surname clusters like everybody wants you to, because so few of them have enough uniqueness from the predictable haplogroups to have any accuracy at all. Also, this is limited to haplogroup R because that's all the data I have collected. Discounts will be available if I've already analyzed them. So, and I already analyzed 50 haplogroups, but there's hundreds of them, and I've done the larger ones. So there will be discounts if I've already done them, and it depends on how recently I've done them. Also, you can look at the big tree to determine if your YSNP branch qualifies, and also special request or welcome. I will be considering adding like a 4-page summary. That will probably be available for a small fee as well. If you're unsure what's involved, then here are some extra presentations that show what kind of analysis will be done. First of all, the first presentation is on step-by-step how I use SAPP, and I pretty much have a cookie cutter there. There's not much variation on SAPP. Also, the data collection portion of it. This goes into how you create a haplogroup project, which you probably want to do. And that way you can start collecting data and use this analysis to jumpstart your haplogroup project. Also, there's a presentation if you don't quite understand what SDR signatures are. This one goes into how to do YSDR signatures. And if you want to find out a little more about AccuSTAP, this is a link to the AccuSTAP page to where you can actually download and buy this product and do it yourself if you want to. And also, if you want to see what really can be done, this is what I've done manually for L21, which is too big of a project for SAPP to handle, which is limited to about 600. This has close to 1,000 testers. And see, this shows you what charting can actually do for you. Here is even more presentations I've done on determine your predictable haplogroup. This is real key because you need to know which scope. And this is a pretty good step-by-step, which you should be able to go through and determine which haplogroup is predictable for your particular part of the haplotree. And this, the next one is if you want to maintain your own chart, this tells you how to create the chart, what's the purpose of each field, and goes you step by step on what needs to be included in an Excel spreadsheet. And if you want to know how SNP prediction works, this is their presentation, and then I have another one on charting and how it works. And then there's a step-by-step on how charting works. And also there is a presentation on statistics for genealogy. This shows you somewhat how the family tree match lists just don't work very well. And then also you need to understand that privacy versus accessibility is a huge trade-off, and currently about half the data that you could actually do is probably private. So developing your own project and getting people to turn off privacy would greatly help you being able to share their information that would be legal.